Hello, this is lesson 4 of Intermediate Java, and today we're going to look at the more concrete concepts of classes and objects. Alright, last lesson we talked about the analogies with classes and objects and like the overall concept of what a class and object is. We had some analogies like a cookie cutter and a cookie. Like the cookie cutter is the class and the cookie is the object. You can make multiple cookies using one cookie cutter. Another thing is a blueprint and like a house. Like you can make multiple houses from a blueprint and you only need one blueprint. So the blueprint is the class and each house is an object. And then you have like a factory and cars. So the factory is the class and the car is the object that comes out of that class. You should have thought up of some analogies for yourself over the last week. If you didn't, that's fine, doesn't really matter. Alright, so now we're going to start talking about the more concrete things. The two main things that a class has is a method, which are the actions an object can take. For a car class, the car would have a drive method. So the car object could call its drive method and drive. And then the second thing are fields. Fields are just variables. They're called instance variables. They are just variables, but instead of being in the main method, which are called local variables, they're in a class. And I'm going to talk about that more in depth later, but basically instance variables are like each object having its own value, but they all have the same variable names. Like two cars have the same variable name. They both have a speed value, but the speed could be different for each one. But they both are called speed. Like they both have the exact same variable speed. The value just might be different. Alright, first thing we're going to talk about are methods. They all have a method header, which consists of these parts. The word public here is known as the access modifier. Generally for methods, you want to have it always on public, and we might talk about that later in like one of the later lessons, but just for now, remember that methods are public. Next thing is the return type. I will talk about that more in detail in a second. And then the name. The name has just the same naming convention as variables. You have the first letter is lowercase, and then every new word starts with an uppercase letter. So this example method, the M is capitalized. Then you have parentheses, and in these parentheses you can put parameters. I'll talk about that in a second. But back to return types. Return types tell you what the method is going to return. So in this case, void means it's not going to return anything. So this void could be replaced with the word int or string or double. And what that means is that the method is going to return that data type. And that's going to be shown in a keyword that I'll show you in a second. But for now, I'll skip that and I'll talk about it here. In here, we have return a plus b. So the return type is an int, and our two integers here in parameters, which I'll talk about in a minute, are a and b. And it's going to return a plus b. So this return keyword just takes whatever's on the right side, and it just returns that value. Now, what does returning actually mean? I'll show you that near the end. Oh, what did I just do? I don't know what I just did. Anyway, so back to parameters. A parameter is another part of the method header. Right here is an example of something that has parameters, and this is an example of something that does not have parameters. Parameters are basically the inputs of a method. So in this add method, it's going to take in an a and a b, right? There's two integers. They don't actually have the letters a and b don't really mean anything here. It's just int is what really matters. You have some int, and we're going to call it a, and then you have a second int, we're going to call it b. Now, you can have any number of parameters you want. I could have like 57 ints or 0 ints, or I could have an int and a string, or I could have any combination I want. But they are like the inputs of a method. That's what you should remember about them. Okay, so here's some example methods. Notice the return types are void and it's printing instead of returning. And these return types have a return type. So an int, it's returning an int. This boolean, it's returning true or false. So this meow is just going to print meow. It's like telling the object to meow. So if this was like a cat object, that would be a method. This add would be some kind of math class or something. This one prints out this method prints out the addition, and this one returns the addition. Generally, you want to return things and not print them, but they're generally more useful. Not always, right? This meow, I would more likely want to print and not return, but this I would more likely want to return and not print. Is greater than 5. Notice a lot of methods will have this little format where you start with is and it returns a boolean. Essentially, it's like asking a question to say, okay, is this thing greater than 5? That's what you're asking. That's what you're asking by calling the method. So this method will just return true if it's greater and not if it's false. Not if it's not. It's going to return false if it's not. All right. Now I'm going to move on to fields. Fields, as I said, are simply variables for objects instead of local variables that you use in your code. They are always private. Before we had methods, they were always public. Instance variables are always private. This is just a common practice that you want to get in the habit of doing because it's good for keeping your data like secure when you're coding. But you don't have to worry about that until much later. Alright, so if they're private, that means we can't just access them like normal. We can't just like say model equals 2. We can't do that. Instead, we have to access them using methods. So that's why I talked about methods first. So here we have these two types of methods called getters and setters. So I'll start with setters. Setters change values. So when I say x equals 2, I would use a setter there, right? If I want to say speed equals 2, I would call this method and input 2 here. So I would do set speed, put 2 in here, and it would say speed equals, if I put 2 in here, this a would be 2. Then if I want to use the speed method, right, if I want to like print out speed, what I would have to do is I would have to use a getter. And in this case, it's the getModel method, but the getSpeed method would look exactly the same as this. So here, notice that this has a return type because it's returning something. You're trying to get something. You're accessing something. So you want something. You're returning it. This one is void because you don't actually want anything back from the method. You just want to put a value into a variable. So if I want to get the model, I would say print, and then I would call the getModel inside of the print. And it's going to return whatever's in the model variable, and then wherever I called it, it's going to print that out. So that's how methods work. Now I'm going to show you how constructors work, and then after that we're going to piece this all together, and it's going to make a lot more sense when you actually see examples. Alright, so constructors are a special method. Notice that there's only 2 words here. So the return type is missing. There's no void here. There's no int here. It's just, there's nothing there. But you do have the access modifier. You want this to always be public on your constructors. Now, you should also notice that the name of your constructor method is the same as the name of the class. This actually has to be the case. Like, it matters. You need to have the name be exactly the same. Alright, so once you have those two things, the computer knows, hey, that's a constructor. So what a constructor does is it takes your information from your class and it turns it into an object, and it gives you that object. So in this, notice that there's nothing actually in here, which means it just makes the object. That's like intrinsically, like, it's just like inferred that it just makes the object. That's like line 1 of this. It just makes the object. That's just like inferred. But these model and speed variables, you might have the question that, hey, why don't these have a value? Why doesn't it say string model equals 2? And the reason for that is it doesn't actually have a value until there's a class. Until there's a, sorry, not a class, until there's an object made. So when you call this method, you make an object, and that specific object now has the default values for model and speed. So model, the default value for a string is null, and the default value for an int is 0. So this car that you're making right here has a model with null in it, and it has a speed with 0 in it. You can also put parameters in your constructors. So I have a string s and an int a, right? This would be the, sorry, this should say model, not make, but it doesn't really matter. So you have a string s and you have an int a that you're plugging into the constructor, and then the constructor makes an object, and then after it makes an object, it's going to set its instance variables to s and a. So here's an example of actually using that in the main method. So I would say car test equals new car BMW 10. Now, what this means is, that you're making a car variable called test, and then you're setting it equal to whatever this method gives you, right? This method is the constructor, so it gives you a car. It gives you a car object. So you're making a variable called test with type cars, right? This is kind of like the same thing as int x equals. Now on the right side it's different. You have this keyword called new, which is something we haven't seen before. You pretty much just have to use this whenever you're making a new object, and that's all you need to know. It doesn't really serve any other purpose than that. So if you took out the word new here, it would look fine. Like I could read it and I would know what you're talking about, but you need to have the word new here because the compiler needs it there to actually make the object. So after you put this new here, then you call the constructor. So you say car, because that's the name of the method, and then in parameters, in the arguments, you put BMW, right? You want a string. BMW is the make, so you put that in here, comma to separate the two, and then you want an integer, so you put 10. Now, what this does is it makes a new car, and it puts BMW in its make instance variable, and puts 10 in its speed instance variable. So now you can call another method called getSpeed, right? Now here you're going to see this is a new thing as well. I haven't actually shown you how to call any methods in the main method yet, but here you have the name of your object, right? We named it test. Dot. Then the name of the method with whatever the arguments are. In this case, the arguments have nothing in them, but you still need the parentheses here. So test.getSpeed. What that does is, if we look back at the get methods, it's just going to return whatever you're asking for. So this getSpeed is going to return the speed. So this is like kind of the exact same thing as saying system.out.println, and then you have an integer here, right? GetSpeed returns an integer, so this whole like little block of text sort of becomes an int. And in this case, it's going to look at the speed. It's going to look at your object, right? So it has 10 as its speed. It's going to read it. It's going to then say, okay, it's 10. So we return 10 to wherever it was called. And it was called here in this print statement. So this print statement will print out 10. All right. So here's another example of actually creating an object with the constructor. You do car test equals new car. Now, here, it looks very similar to int x equals 10, right? Car is your data type, int is your data type, test is your name, x is your name. You put an equal sign, and then whatever it's equal to is on the right. So in this case, we want 10 for an int, and we want a new car object for our car. That's one of the best ways to try to understand this, is that they are very analogous to primitives. They kind of do the same thing, right? Car is a data type, just the same kind of way int is, and the same way string is. Alright, so here's some more examples of using an object inside of the main method after you've created the class. So you say car test equals new car, right? That makes a new little car object, It puts it in the test variable. Then you take that car and you dot set speed 10. Now set speed is going to change the speed to 10, right? You plug in 10 here and says speed equals 10. Now, in that object, you have a 10 as the speed. Then it calls the getSpeed method here. Well, it's going to try to get the speed. So the speed, as we know, has been set to 10. So this speed will end up equaling 10. It's going to give back 10 into this print statement, and it will print out 10. That is how it works. All right. For the exercises for today, I want you to create a class called rectangle. Give it two instance variables, length and width. They're both ints. Then add setters and getters for both the length and the width, each of them. So I want 4 in total. Then I want a constructor with parameters. So I want a constructor that has like 2 ints in its parameters, and it sets the length equal to 1 and the width equal to another. And then the final thing I want is a getArea method. And that's going to return the length multiplied by the width. That's all I need for the rectangle class. For the cartoon class, there's a lot less to do. All I want is you to just make a class called cartoon and have 2 strings. One's named name, and then one's named channel. And add the setters and getters for both of them. So I want 4 setters and getters in total for the cartoon class. And that is all. That is the 4th lesson for intermediate Java.